I chose CDK4 because of its affiliation with malignant melanoma. Malignant melanoma is a disease that I wish I knew nothing about, but sadly I know a little bit about it. My mom was diagnosed when I was 23, and just for some of the backstory, when I was getting ready to finish up with school round one, I was getting ready to do my last semester. I was planning on working for the government. I had a mentor in the FBI, and I spoke with him near the end of school, and he told me that there was a hiring freeze with all the government agencies, and they didn't know when it would end. So he offered me some advice and said, maybe become a flight attendant to maintain Russian fluency, find an airline that flies into Russia. You'll be able to converse with people and keep up with language, and then when the freeze is lifted, come back. So, well, добро пожаловать на Aerokcompany Delta. I got hired by Delta Airlines, and just before I was about to leave for 6 weeks of training in Atlanta, my mom said, "Oh, would you look at the back of my head? I thought I cut my head on something, but the scab's not healing." And so she parted her hair, I looked at the back of her head, and there I saw a mole that was about the size of the tip of my finger in a big, like $half size circle of black and brown. And not knowing anything about what I was looking at, I just said, "Well, that doesn't look right. I think you should get that checked out." So off I went to Atlanta, and for 6 weeks I spoke to my mom almost every day, periodically asked her, whatever came of that, what was it, and she just kept saying she didn't know. But the night before we were getting ready to wrap up training, Delta extended us tickets to invite close family members to come and see how everything went down. So I called my mom to ask her and my stepfather to come to Atlanta, and that was when she told me that she was diagnosed with stage 4 malignant melanoma. My mom. So she would have hated me adding this picture because this is during chemotherapy, so she was really puffy, so I had to add that other picture first. So melanoma. Melanoma is one of 3 of the most common types of skin cancer, the other 2 being basal cell carcinoma and squamous cell carcinoma, but malignant melanoma is by far the worst, and it is attributed to the most deaths related to skin cancer. There are certain factors involved in melanoma, such as exposure to UV light, as we've learned through this semester as well as previous semesters. UV light causes breakage to DNA. UVB causes double-strand breakage, where UVA actually causes single-strand breaks. There are some genetic components to it. If you have a close family member who has melanoma or any type of skin cancer, you're more likely to get skin cancer yourself. There's an age and gender component. People under 50 are usually women who are diagnosed. Over 50, it's men. Annual screening is recommended because even under the age of 30, it is one of the most commonly diagnosed cancers in people, especially for women. If there are any atypical moles, you want to keep an eye on them for growth. The degree of growth correlates to the likelihood of there being a problem. Xeroderma pigmentosum is another genetic characteristic that attributes to it. People who have xeroderma, I'll just call it XP. People who have XP are very fair in complexion and burn very, very easily. Their skin lacks the ability to repair any DNA damage. So screening is the best way to find melanoma. It's recommended that you go every year. May is Melanoma Awareness Month, and the black ribbon is its sign. When getting screened for melanoma, the doctor will usually go through the ABCDs of melanoma, A being asymmetry, B for border, C for color, D G diameter, they reference a 1/4 inch, but it correlates to a pencil eraser diameter. And then of course you want to look for evolving size, shape, and color. So the CDK4, I'm sure everyone remembers from this the cell cycle. CDK is one of the cyclin-dependent kinases of a large family of them. It interacts with cyclin, and then in humans there are quite a few cyclins as well, and they create a complex. And cyclin D is what complexes with CDK4, and also CDK6 is kind of thrown into that mix as well. Their concentrations fluctuate throughout the cell cycle, and it drives the cells through the G1 checkpoint into S. They do that by phosphorylating the retinoblastoma gene product, RB. RB has an anti-tumor mechanism. It inhibits cells from progression until they're ready to divide, and this complex is also inhibited by P16. So with mutations, CDK4 is a potential oncogene. I guess that cat's already out of the bag. It can be activated by overexpression, decreased degradation, and activation of point mutations. Wow, my mouth is dry. Overexpression of CDK4 has been identified in quite a number of cancers in humans, including melanoma, glioma, sarcoma, carcinoma, breast cancer, colorectal cancer, as well as prostate cancer. All of the mutations in CDK4 are found on exon 2. It's also in exon 2 where there's a binding site for that inhibitor, P16. One mutation of note is R24C. What is that? So arginine is replaces cysteine in that mutation, and it is more, they see that in a like a familial correlate with them. They're also, the mutations in CDK4, they're also associated with tumorigenesis, so I included a little bit about how, like when you have that first cell, and then it starts to have that uncontrolled growth and develops into the tumor, it creates its own network of blood supply. That's the angiogenesis. And then with the blood supplying the tumor, it can then get into either the lymphatic system or into the blood system and metastasize. So when dysregulation of the CDK4 pathway is involved, obviously, in the loss of cell cycle control, and then that results in uncontrolled growth, tumor heterogeneity, invasion, and metastases. Thank you. Dying. Oh, so much better. So with melanoma, the pathway is associated with activating the genomic alterations in over 90% of the cases. In both the humans and the mouse models, activated CDK4 pathway and mutant BRAF, or NRAS, is a powerful combination in transporting melanocytes. So you may have heard of, actually I'm not sure this, the BRAF gene, which is correlated to breast cancer, is also correlated to melanoma. So the gene in the homolog for CDK4 in humans in C. elegans is CDK4. It pretty much works the same way, except with the exception of cyclin. Cyclin D is actually the only cyclin that C. elegans produces, and the complex, and that protein is CYD-1, and so the complex is just that CYD-1, and the CDK4 complex, and again, just like in humans, it acts as a cell cycle regulator from G1 to S progression. when considering the knockdown of CDK4, I really wasn't sure what to consider. I really wasn't sure what would happen, because ever since being a zygote, like, our whole bodies have been doing nothing but cell division, right, until they go into senescence. So I thought, would there be like overgrowth? Would there be masses anywhere? Would it be limited to any specific area? Would there not be any offspring? Would it somehow shut that down? I really didn't know. I didn't know it would start without me doing anything. So the results that we were given the phenotypes for suggested that we'd see a protruding vulva, dumpy, sterile, larva arrest. I think this one might be an example of the protruding vulva, but it is, okay, but that was the only one I could see on the plate. And this is actually the same plate this guy is, right? Well, I guess girl is right there. Then I found from that same publication, just a year later, another publisher, he mentioned that the mutants defective in the cell cycle arrest, they show defects in mobility, giving them an uncoordinated phenotype. And so that's why I included that video again. Just one more time. The worms on my plate were like really coiled up. Some of them made like that omega shape, but I didn't, that wasn't captured on this video. In conclusion, so I recognized that one of the errors I made with the positive control was that I used dumpy, which I should not have used, because that was actually one of the phenotypes to look for in the RNAi experiment. Additionally, more time or extra experiments would be good to see the progeny for different phenotypes for maybe sterility. Like, if they were given more time, would there be a decrease in the offspring that was seen? Another publication that I had found said that the CDK4 RNAi does not block embryonic divisions. So given that, I guess that's why there was some offspring to look at. That mutants didn't show defects in those specific tissues. The human correlate gene has multiple areas where for poly A sites to add on, giving it a lot of stability. So maybe testing to see if the reason that these mutants don't show defects, maybe it might be because of the poly A tail. So that might be another thing to look at in more testing. Any questions?
Did you see the dumpy phenotype in your experimentals?
I did. That one was dumpy. There's one behind Watch on YouTube. And there might have been another one behind.
Can you pull that up on YouTube?
I can play it.
If you click the title,
With that.
can you expand it so we can see the? Yeah, and just play it again.
There is new hope for a green energy future. At National Grid, we have a clear roadmap to achieving net zero and deliver more affordable energy to our customers using our existing infrastructure so we can save the planet and save some money along the way.
That one also was, this one might be like a dumpy and protruding vulva more, but I'm not really too sure about that. So that was dumpy. I think that one actually might have been dumpy, and that one definitely. It might have been this one.
Thank you.
Yes.
So,
Well, the RNAi isn't 100%. It's knocked down, not knocked out. So the phenotypes will still be expressed in some cases where it wasn't impacted by the RNAi.
Any other questions?